Hello all. Today we're going to calculate the margin of error for a sample proportion. Uh, Below we have the formula. We have Z critical. So this is our critical value. And right here, this is our standard error. So if we do like a survey or a poll, we can find the margin of error given the data from our sample. I'll go through a couple examples here, show you how this works. Uh, so here we go. Here's the first example. Suppose you surveyed 1,000 people in the United States and 62% think the president is doing a good job. I don't know if that's true or not, but we're just going to use these numbers for an example. Assuming you want a 95% level confidence, what is the margin of error for this survey question? So we have our sample size here, which is N 1,000. Okay, we have our P hat, our interest, which is 62%. I want to change that to a decimal. Just take your percent, divide by 100, you get 0.62. And we're at a 95% level of confidence. This is going to help us get our critical value here. So if we're looking for Z critical, okay, you need to take a look at a chart. I took the liberty of writing down these values here. So we're wanting a 95% level of confidence, and our Z critical value is going to be 1.96. So that's what we're going to plug into the formula here in just a second. We'll make sure everything looks good. We're going to put 1.96 here. Okay, so let's go to a blank page. And let's just plug and chug, just like algebra. For Z critical, we had 1.96. I'm going to times that by, now this part gets a little tricky here. For those who are not so great at algebra, I need to go back, check my P hat, which is 0.62. I'm going to write 0.62 here. Now this part in parentheses, you're doing 1 minus P hat. You can simply just go ahead and do that. 1 minus 0.62, that's going to be 0.38. And then I'm going to divide that by my sample size, which was 1,000. So let's go back here, plug in 1,000. All right, and we'll make sure everything looks good. Now, right here is like the biggest problem for most people. When you plug it into the calculator, uh, do order of operations. Let me scoot this down a little bit here. Okay, there's my calculator. I'm going to go ahead and punch in 0.62. I'll go ahead and times that by 0.38. All right, looks good. Hit enter. Now I need to divide that. Go ahead and divide that answer by 1,000. So 1,000, and then hit enter. Now you get a very small decimal, and it's written, however you want to say it, in scientific notation. Um, this is another algebraic kind of problem. Uh, 2.356 to the negative 4 power, that is basically this right here. I want to hit second x squared because I want to square root all this. I want to write 0.000 and then 2. Alright, so I look at this number in front of the decimal. I mean, it's got to be in scientific notation if there's only one number in front of the decimal and it's between 1 and 9. You already have one number in front of the decimal, and since it's negative 4, the exponent's negative 4, you got to move it over 3 or 4 spaces total. We don't have any numbers in front of 2, so that's why these zeros come into play. And you can just finish it out by writing 3, 5, 6 if you want. 5, 6, and then hit enter. Okay. Now, I need to copy that down somewhere. I'll write that down on my iPad. I will write, let's go 4 numbers after the decimal. We'll go 0.0153. That should give us a pretty accurate number to find the margin of error. So now we're going to times that by, I'm going to minimize this for a second. I don't know why it did that. I want to times these two numbers together. Now give us our margin of error for our sample proportion. So 1.96 times 0.0153. Get my handy dandy calculator here. 1.96 times 0.153. Everything looks good. Hit enter. And we get 0.0299, which is roughly, guys, just right under 3%. Okay, how do you change a decimal to a percent? You times it by 100. So you got a 2.99% margin of error. Okay, which is right under 3%. All right. Here's another example, and you can try this on your own. You can pause the video, see how well you do with it. Note that I'm using a different confidence level, 90%. I'm going to change colors here. Let's go green. Here's my sample size. So suppose out of 500 students selected at random at Shawnee State University, 62% had a GPA higher than 2.7. Assuming a 90% confidence level, what is the margin of error? All right, so I'm going to go ahead and set this up. Again, I got my critical value times square root of all this. Got p hat times 1 minus p hat. This little section here that I'm writing down is the standard error. Okay, all that divided by the sample size. So let's get some data going here. Let's crunch some numbers. Sample size is 500. My p hat, my interest proportion, 62%. Going to change that to a decimal right off the bat. Just take that percent, divide by 100. If you're changing a decimal to percent, times by 100. And then we need to find our critical value. Since we're at a 90% confidence level, Okay, we can go back here. Okay, you'll have a table available to read. Okay, there's my 90% confidence level. Here's my Z critical, my critical value. So 1.645 is what I'm going to use. Oops, I went one too far. 1.645. Now I have all the information I need to plug into my formula. So M for the critical value goes 1.645. Just straight plug and chug, guys. Don't get any better than this right here. Okay, my P hat, 0.62. Okay. I think I'm going the wrong way. I'm sorry. Actually, I used the same P hat as the first example. That was kind of silly of me. 0.62 here. And then 1 minus P hat, go ahead, minus it. 1 minus P hat, 1 minus 0.62 is 0.38. Then I have a different sample size, I do know that, which is 500. Okay, let's go ahead and work out this standard error first. So we'll pull up the calculator, go through the motions again. I'll clear this off so you can see it pretty well. Again, we have 0.62 times 0.38. Okay, there's my 0.2356. Now we're going to divide by a different sample size here. Divide that by 500. Okay. Now again, you get a number in scientific notation on a calculator. All right, so what would that be? That would be 0.0004712. Now I can go ahead and square root that number. So I'm going to hit second, x2. That's not what I wanted to do. Second, x2. Point, need 3 zeros. And then the 4. And you can put 712 in there if you want. Hit enter. We get 0.0217. Sounds good. I'll go with that. So that's my standard error. 0.0271. And then now I can times that by my critical value. Okay, so I got everything in place right here. Now I'm going to go ahead and multiply that out. So let's bring that calculator back up and punch it in, punch it in. You can do this second, enter. No, not really. Second answer, I'm sorry. So it'd be second negative. There's my answer. I'm going to go ahead and times that by my critical value, 1.645. Click, click, click. And then click again, hit enter. Okay. Now, I get a decimal of 0.0357, which is my margin of error. And if I want to put this in percentage form, it's going to be 3.57%. Okay, so that is the margin of error for our sample proportion. Well, guys, hopefully this kind of clears things up for you. Until next time, have a good one, and rock is right.